Hello, my name is Daniel, and today we will be solving the AMC 10B from the year 2004. So let's get right into it. First problem, each row of the Misty Moon Amphitheater has 33 seats. Rows 12 through 22 are reserved for a youth club. How many seats are reserved for this club? Okay, so what we need to find is how many rows are in rows 12 through 22. So first thing that you shouldn't do is 22 minus 12, because that means that row 12 is not included, but row 22 is. But then what we want here is that row 12 and 22 are both included, and so this should be 22 minus 12 plus 1, which is 11. And so 33 multiplied by 11, it's 363, so it's C. Second problem, how many two-digit positive integers have at least 1 7 as a digit? Okay, so let's say that there's something 7, so 17, 27, 1, 2, 3, 4, 5, 6, and then let's skip 7, 8, 9. So we skip 7 because we already have a 7 for the 7 something. So this will be 0 to 9, this will be 10, and this will be 8, right? So 10 plus 8, 10 right here, 8 right here, equals 18. The answer is B. Third problem, at each basketball practice last week, Jenny made twice as many free throws as she made at the previous practice. At her fifth practice, she made 48 free throws. How many free throws did she make at the first practice? Okay, so first practice, second practice, third practice, fourth and fifth practice, she made 48 free throws, and so at each practice she made twice as many as the previous week. So that means at the fourth practice she made 24, this is divided by 2. Also same thing, divided by 2, this is 12, divided by 2, this is 6, and divided by 2, this is 3. So at the first practice, she made 3 throws. The answer is A. Fourth problem, a standard 6-sided die is rolled, and P is the product of the 5 numbers that are visible. What is the largest number that is certain to divide P? Okay, so let's say, that for each scenario, 1, 2, 3, 4, 5, 6. One of these 6 numbers are not visible, right? Because that's what will happen. The 5 numbers that are visible will have to be multiplied, and so if we don't get 1, then that doesn't matter because 1 is just everywhere, right? It's 2 is 1 times 2, 3 is 1 times 3, so 1 doesn't matter. If we don't get 2, that would be 3 to the first power. No, let's do 2 first. That would be 2 to the third power because of 2 here and 1 here, and multiplied by 3 to the second power, multiplied by 5 to the first power. If we don't get 3, then that would be 2, 4, 6, 2, so it's 2 to the fourth power times 3 to the first power times 5 to the first power. If we don't get 4, that would be 2 to the second power times 3 to the second power times 5 to the first power. If we don't get 5, this would be 2 to the fourth power, 3 to the second power, and then if we don't get 6, we would be 2 to the third power times 3 to the first power times 5 to the first power, and so the smallest exponent of everything would be 2 to the second power times 3 to the first power times 5 to the 0th power, so it would be 2 squared times 3, which is 12, and the answer is B. But you don't have to go through everything like this. There is like a more simpler shortened way, and so it's that 5. If we don't get a 5, then we can't have 5, and so it is not divisible, and so there is no 5. And then if we don't get either 3 or 6, then it is not divisible by 3 to the second power, but it has to be divisible by 3 to the first power because there is at least one of each end, and it can be only one missing at a time, right? So 3 or 6. This would be only one of 3, and so if we don't get a 4, because 4 this equals 2 to the squared, and so the smallest power of 2 would come if 4 was out, so that would be 2 times 6, so that would have to be only 2 squared, so no 5, so there is nothing for that, and then we have only 1 3, and we have only 2 2's, and so we would have 3 times 2 squared. This is also 12, and so that's also how you could get B. Problem number 5. In the expression c times 8 to the bth power minus d, the values a, b, c, and d are 0, 1, 2, and 3, although not necessarily in that order. What is the maximum possible value of the results? Okay, so let's say we want the maximum possible value. So here d would have to be 0, right? And so 0 is definitely in d, and we would have to debate where the 1 could go. If 1 is the b, then it's c times a. This would equal 6. If 1 is in the a, then this would just equal c. This would be 3 at the maximum. And if 1 is c, then it would be 8 to the bth power. So it could be 3 squared or 2/3, and so the maximum value would be 9, right? And so the biggest thing could be 9. So the maximum possible value is 9, so the answer is D. Number 6, which of the following numbers is a perfect square? And so for it to be a perfect square, yeah, so this is 99 times 98 factorial squared, right? And 99 is not a perfect square, so it doesn't work. Yeah, and so if we look at this is 100 times 99 factorial squared, right? So, and 100 is 10 squared, so it's 10 squared times 99 factorial squared, and so this is a perfect square. The answer is C. Number 7, on a trip from the US to Canada, Isabella took D US dollars. At the border, she exchanges them all, receiving 10 Canadian dollars for every 7 US dollars. After spending 60 Canadian dollars, she had D Canadian dollars left. What is the sum of the digits of D? Okay, so she took D US dollars, and so D US dollars would be equal to 10 over 7 D Canadian dollar, right? And so this will be 60 Canadian dollars. She had D Canadian dollars left, so 10 over 7D equals 60 plus D. So that will mean that if this comes here, then 3 over 7D equals 60. D equals 60 times 7 over 3. This will be 140. And so the sum of the digits of D is 1 plus 4 plus 0. So the answer is 5. So it's A. Problem number 8. Minneapolis to St. Paul International Airport. Minneapolis-St. Paul International Airport is 8 miles southwest of downtown St. Paul and 10 miles southeast of downtown Minneapolis. Which of the following is closest to the number of miles between downtown St. Paul and downtown Minneapolis? Okay, so we have 8 miles southwest of downtown St. Paul. So it's southwest, so if there's St. Paul, it's 8 miles southwest, like that. 10 miles southeast, so it would be like that. It wouldn't be as much, so it would be like about this much. No, maybe like this much. Let's say yeah, this is Minneapolis, and this is 10 miles, this is 8 miles, and the number of miles between downtown St. Paul and downtown Minneapolis, right? So this would have to be, so this would be 45 45 90 triangle, and this would also be a 45 45 90 triangle. And so since this is 10 and this is 8, this is 8, so this is 4 root 2, 4 root 2, and this is 5 root 2, and this is 5 root 2. And so if we put like this, then we can use this triangle and use the Pythagorean theorem. And so this much would be 5 root 2 minus 4 root 2, so this is root 2, and then this much would be 5 root 2 plus 4 root 2, so this is 9 root 2. And so yeah, and so the downtown St. Paul and downtown Minneapolis, that will be distance would be root of root 2 squared plus 9 root 2 squared. This is root 2 plus 81 times 2. This is root 2 plus 162. So this is root 164. And so root 164 is between root 169 and root 144. Root 164 is definitely closer to root 169 than root 144, and this is equal to 13, so the answer is 13, it's A. Number 9, a square has sides of length 10 in a circle center and one of its vertices has radius 10. What is the area of the union of the regions enclosed by the square and the circle? So the square has sides of length 10, length 10 square. So this would be 10. And a circle center that one of its vertices has radius 10. Okay, so it will be like a quarter circle. And what's the area of the union of the regions enclosed by the square and the circle? Okay, so we need the full circle. And so it would just be like that. What is the area of the union of the regions? So we would need to find this area of the square. And then this is also 10, right? So this much is 10 squared, this is 100, until here. And then we will need to find the remaining 3/4 of the circle. And so this is 100, this much, plus 3/4 of the circle, and the circle has radius 10, right? This is radius 10, so times 10 squared pi, this is 100 plus 3 times 25 pi, this is 100 plus 75 pi. The answer is B. Problem number 10. A grocer makes a display of cans in which the top row has 1 can and each lower row has 2 more cans than the row above it. If the display contains 100 cans, how many rows does it contain? Okay, so if the display contains 100 cans, right? So the top can has 1, and the second has 3, 5, 7, 9, all the way to n. And then if the display contains 100 cans, so the sum until n would be n squared, since this is just an odd number sequence. So this is 100, so n equals 10. So the n is 10, so the bottom row would contain 10. The answer is D. Okay, so problem number 11. Two 8-sided dice each have faces numbered 1 through 8. When the dice are rolled, each face has an equal probability of appearing on the top. What is the probability that the product of the two top numbers is greater than their sum? Okay, so let's say that the two top numbers are A and B, and they have to be greater than their sum, right? So A, B have to be greater than A plus B. So this means that A minus B is greater than 0. A minus 1, B minus 1 is greater than 1. And so A, B, no, so this should be, so the possibilities of these are 0, 1, 2, 3, 4, 5, 6, 7, 8. No, not 8, because A is able to be 1 through 8, right? And so same thing for here, 0, 1, 2, 3, 4, 5, 6, 7. And so, so 0 can't be involved in anything, right? Because that would make the whole thing, because that would like immediately make the whole thing 1, and this would not, and that would never be able to, suffice. So let's erase 0 and 1, and then we have 7 by 7 left, right? And so our total and so the probabilities would be 7 squared, right? Because we can do any combination of these, right? But then we have to minus 1, right? Because if we do 1 and 1, then this would equal 1, and we don't want the equal, we just want this to be greater than, and so we have to subtract by 1. This is 49 minus 1, this is 48. And so the probability would and so the number of so there are 48 ways to make this happen, and the total number of ways would be there are 1 through 8, and there are two dice number 1 through 8, so they would be like in any way, so it would be 8 squared, and so this is 64, and so we have 48, we have 64, and we want the probability, right? So we want 48 over 64. This is let's say 412 over 16, this is 3 over 4. The answer is 3 over 4, which is C. Number 12, an annulus is the region between two concentric circles. It's the shaded region. The concentric circles in the figure have radii B and C, with B is greater than C. Let OX be the radius of the larger circle. Let XZ be tangent to the smaller circle at Z, and let OY be the radius of the larger circle that contains Z. Let A equal XZ, Y equals Y, D equals YZ, and E equals XY. What is the area of the annulus, right? So the area of the annulus is first B squared pi minus C squared pi, right? And so this is pi times B squared minus C squared, right? But then if you look at this right triangle, what we see is that A squared plus C squared equals B squared. So that means A squared equals B squared minus C squared. So this is the same thing as A squared. This is pi times A squared. This is A squared pi. This is the same thing as A. The answer is A. Problem number 13. In the US, coins have the following thicknesses. Penny has 1.55 millimeters, nickel 1.95 millimeters, dime 1.35 millimeters, quarter 1.75 millimeters. In a stack of these coins, exactly 14 millimeters high, how many coins are in the stack? Okay, so 14 millimeters. This will be 1400 times 0.1 times 0.01, and then this will be the total. And then penny will be 155 times 0.01. Nickel will be 195 times 0.01. Dime will be 1.35. No, this will be 135 times 0.01. And the quarter will be 175 times 0.01. So let's erase all the 0.01s on everything like this. And so total 1400, right? Oops. Total 1400. And then P is 145, N is 195, D is 135, Q is 175. Okay, so let's divide by 5, right? So this could be 280. And then this could be 31. This will be, what is it? Yeah, this will be 30, 39. This will be 27, and this will be 35, right? And so the only way that this could be so it's not the only way, but the simplest way that this could be possible is that this is all quarters, because 280 is divisible by 35, right? So 280, this is 35 times, what is it, 8? So 35 times 8, 40. Yeah, so it is 280. So let's just say that there are 8 quarters and nothing else, right? How many coins are in the stack? There are 8 coins. The answer is 8. It's B. And for the next problem, problem number 14. A bag initially contains red marbles and blue marbles only, with more blue than red. Red marbles are added to the bag until only 1/3 of the marbles in the bag are blue. Then yellow marbles are added to the bag until only 1/5 of the marbles in the bag are blue. Finally, the number of blue marbles in the bag are doubled. What fraction of the marbles now in the bag are blue? Okay, so we have red and blue, with more blue than red. So let's say that we have 2 blue and 1 red. Red marbles are added to the bag. Are added to the bag until only 1/3 of the marbles in the bag are blue. So if we add 3 more red, then 1/3 would be blue, and then yellow marbles are added to the bag until only 1/5 of the marbles in the bag are blue, right? So let's say that these are yellow until only 1/5 are blue. So the total has to be 10, like this. It will be like this. So out of 10, 2 are blue, so that means 1/5 are blue. Then the number of blue marbles in the bag is doubled, so this will be 4 blue now. What fraction of the marbles now in the bag are blue? So there are 12 total, and 4 of them are blue, so this is 1/3. The answer is C. Number 15. Patty has 20 coins consisting of nickels and dimes. If her nickels were dimes and her dimes were nickels, she would have had 70 cents more. How much are her coins worth? Okay, so nickels are 5 cents. Dimes are 10 cents, as everybody knows. If her nickels were dimes and her dimes were nickels. Okay, so let's set a unknown value. Let's say that she has X nickels and 20 minus X dimes. And so if her nickels were dimes and her dimes were nickels, she would have 70 cents more. So right now she has 5x plus 10, 20 minus x, but then she would have 70 cents more if her nickels were dimes and her dimes were nickels. So this plus 70 equals nickels were dimes, so 5 times 20 minus x plus 10 times x. So if we divide 5 by the left and right, it will be x plus 2 times 20 minus x plus plus 14. This equals 20 minus x plus 2x, right? And so this would be minus x. So it's 40 minus x plus 14 would be 20 plus x, right? So 40 minus 20 plus 14, this would be 34 equals 2x, x equals 17. How much are her coins worth? So she has this much so she has that much initially. So if we do it 5 times 17 plus 10 times 20 minus x is 20 minus 17, this is 3. This is 35, this is 85, right? So this is 85 plus 30, this is 115. So this is 115 cents. This is $1.15. So it's $1.15. It's A. And problem number 16. No, number 16, yeah. Three circles of radius 1 are externally tangent to each other and internally tangent to a larger circle. What is the radius of the large circle? So there are three circles of radius 1, and then they are internally tangent to a larger circle. What is the radius of the large circle? So what we want is from the center, let's say this is the center, what we want is this distance, right? And so yeah, we want that distance. But then what we have is three circles of radius 1, right? So if we put the centers like this, we can connect them like that and that and like that. And yeah. And since this is the middle, the line to the middle, this much would be 2/3 of this whole line, right? So this is radius 1, so this is 1, this is 2, and so this whole thing will be √3, right? And so this line will be √3 times 2/3, and then we need to add this much more, right? And then that's the radius plus 1. So this will be 2√3/3 plus 1. This is all over 3, so it should be 2√3 plus 3/3. This is D. The answer is D. Number 17, the two digits in Jack's age are the same as the digits in Bill's age, but in reverse order. In 5 years, Jack will be twice as old as Bill will be then. What is the difference in their current ages? Okay, so let's say Jack is 10A plus B years old. Okay, Jack is 10A plus B years old, and Bill is 10B plus A years old. In 5 years, Jack will be twice as old as Bill will be then. So 10A plus B plus 5 will equal 2 times 10B plus A plus 5. What is the difference in their current ages? Okay, so their difference, this is the absolute value of 9A minus 9B. Yeah. So this would be 10A plus B plus 5 is 20B plus 2A plus 10. And so 8A minus 19B equals 5, right? A and B are single digit numbers. So B would be a small number. B would be like 1, I think. No, 1 wouldn't work. So let's say B is 2, then that would make 8A equals 5 plus 38. And so that won't work. Let's say B is 3. Then no, actually B works even if it's 1. So B is 1, that will mean 8A equals 19 plus 5, which is 24. So A would be 3, right? So A is 3 and B is 1. So their current ages is 31 minus 13. So this is 16, right? No, this is 18. Yeah, so the answer is 18, and you can also use this formula when you get A and B. So like you could be, it's the absolute value of 9 times A, so this is 9 times 3, minus 9 times 1, so it's 9. This could be the absolute value of 9 times 2, so this is 18. Yeah, that's another way that you could have gotten 18. The answer is 18, it's B. Number 18, in the right triangle ACE, we have AC equals 12, CE equals 16, and EA equals 20. Points B, D, and F are located on AC, CE, and EA respectively. So AB is 3, CD is 4, and EF is 5. What is the ratio of the area of DBF to that of ACE? Okay, so AC is 12. Okay, so what if... So what we need to find out is this length right here, because if we have this length, then we can calculate the area of this triangle, and we also want this length, right? Because that way we can calculate the area of this triangle, right? And so since this is a 3 to 4 to 5 triangle, and this is also a 3 to 4 to 5 triangle, and since this is 5, this would be 3, this would be 4. And so DEF, that's this triangle here, this would be 12 times 3 times 1/2. This is 18. And ABF would be, this is 4, right? So this much will be 12. Since the whole thing is 16, right? So ABF, so this is 12. So ABF is 3 times the height is 12 times 1/2, which is also 18. And CDB, this would be 9 times 4 times 1/2. This is also 18. What is the ratio of the area of DBF to that of ACE? So the area of DBF would be the whole thing, which is, this is 12 and this is 16, so 12 times 16 times 1/2 minus these 3, right? 3 times 18. This is 6 times 16 minus 3 times 18. This is 6 times 16 minus 9, right? So this is 6 times 7, this is 42, and to that of ACE. And ACE, this is the whole thing, so it's 12 times 16 times 1/2. This is 12 times 8, this is 96. So the answer is 42 over 96, which is the same as, divide by 6, this would be 7, this would be 1/6. This is 7 over 16. The answer is E. So problem number 19, in the sequence 2001, 2002, 2003, each term after the third is found by subtracting the previous term from the sum of the two terms that precede the term. For example, the fourth term is 2001 plus 2002 minus 2003 equals 2000. Okay, so let's subtract 2000 from everything since it's getting cumbersome. So the terms will be 1, 2, 3, and then so on. So it will be 1, 2, 3, and then 1 plus 2 minus 3 equals 0. 2 plus 3 minus 0 would be 5. 3 plus 0 minus 5 would be minus 2. 5 minus minus 2 would be 7. 5 minus 2 minus 7 would be minus 4. 2 minus 7 minus 4 equals 9. And so if you see, the odd numbers would be 1, 3, 5, 7, 9. But the even numbers are going 2, 0, minus 2, minus 4, right? And so what we want is the 2004th term. So what we're caring about is the even numbers. And so this is the first even number, this is the second even number, the third even number, fourth even number, and so this will be getting to the nth even number. So this would become 4 minus 2n, right? And so if it's the nth even number, then it would be 4 minus 2n, right? And so if n is 1002, because 2004 is the 1002nd even number, then this will be 4 minus 2 times 1002. This is 4 minus 2004. This is minus 2000, right? And so the 2004th term will be minus 2000, but then keep in mind that we subtracted 2000 from everything, so we had to add 2000 more, right? So plus 2000. This would equal 0, so the answer is C. Problem number 20. In ABC, points D and E lie on BC and AC respectively. If AD and BE intersect at T so that AT over DT is 3 and BT over ET is 4, what is CD minus BD, right? Okay, so let's say that the ratio, so the ratio is 3 to 1, and the ratio is 4 to 1, right? And then, since this is 4 and this is 3, let's just say that this line, this line is 12, right? And then this would be 4. No, let's say that the area is 12, 12, and since this is 3 to 1 and the height is the same, the area will be 3 to 1, right? So this area will be 4, and since this is 4 to 1, this area would be a 3, and since this is 4 to 1, this area will be 1, right? What is CD over BD, right? So the total area is 1, but if we put a line right here, then that would mean that that would mean that if CD is X and EC is Y, then this will be, if this is 4, this is 12, this is 3, then this would be 3 to Y, this would be X. So X plus Y would be 1, right? But then 3 plus Y to X would be 3 to 1, right? Because it will be this triangle and this triangle, you see. So this would be 3 and this would be 1. So that will also be 3 to 1. So 3x equals, let's write that in black. 3x equals 3 plus y. And same thing with this here, these two. 4 plus x 2y equals 4 to 1. So 4y equals 4 plus x, and so y equals 3x minus 3. Let's get rid of this one. Y equals 3x minus 3, and y equals 3x minus 3, and since we can put that into here, we would say that 3x minus 3 times 4, this would be 4 plus x. So 12x minus 12 equals 4 plus x. So 11x equals 16, right? So x equals 16 over 11. What is CD over BD? So CD is 11. So CD is 16 over 11, and this will be over BD, and BD is 4. So this will be 4. So this will be 4 over 11. So the answer is D. Number 21. Let 1, 4 all the way to 9 and let 1, 4 blah 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 and 9, 16 blah 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 be two arithmetic progressions. The set S is the union of the first 2004 terms of each sequence. How many distinct numbers are in S? So the two arithmetic progressions so the first one is 1, 4, and it's arithmetic, so it increases by a constant number. So it will be like 7, 10. So this would be 3n minus 2. And 9, 16, this would be 9, 16, and then add by 7, right? So it's 23, 30. So this would be 7n plus 2. And so the union of the first 2004 terms of each sequence, so we will need the 2004 terms will be, here will be 2004 and here will be 2004. So there will be at least 4008, right? So there will be at least 4008 minus the number of the numbers that are in both, right? And so let's say that 3a minus 2, and then this has and then this has to be a different like a different number, right? Because we don't know if they come from the same place. So 3a minus 2 equals 7b plus 2, and so 3a minus 7b equals 4. And so how many distinct numbers are in S? So the number so a and b have to be integers, and 3a minus 7b has to be 4. So and here it says the first 2004, so we have the limit is the 3n minus 2, and then we put in 2004. This would be 6012 minus 2, so this would be 6010. And so if And so let's say 3a minus 7b equals 4, right? So x could be I don't know, no, not x, a could be like 1, no, a could be minus 1, and no, a can't be minus 1. A could be I don't know, 6, and b could be 7, no, not 7, b could be 2, and so that way it would be 6 times 3 minus 7 times 2 equals 4. And another way could be, yeah, and since we've got these two values, what we can do from here is multiply a by 7, and then multiply b by 3, right? And so no, and then add by 7 and add by 3, right? Because what we're doing is making 3a minus 2 equal to 7b plus 2, right? And so 6 plus 7, so this would be 13, and 2 plus 3, this would be 5. And then so if you want to check, you could check like 3 times 13, this is 39, minus 7 times 5, this is 35. This is also equal to 4, so it matches up. And so what we are going to do is we're going to like keep adding 7s and keep adding 3s to 2, and so we can reach 6010, right? And so this sequence in itself would be would be a new arithmetic sequence, right? And so this would be 2, 5, and then add 3, 8, and then 11, 14, and then so this would be 3n minus 1. Then this would be 6, 13, and then this would be 7n minus 1, right? But then this has to be less than 2004. So 7n minus 1 has to be less than 2004. So 7n has to be less than 2005. And so if we divide n by 7, so if we divide 2005 by 7, we get 2, 14, 60, 9, 8, 56, 45, 6, 42, and so n's maximum value is 286. So there are 286 overlapping values, right? So what we get is 4008 minus 286. This is 3,722. So the answer is A. Problem 22. A triangle with side length of 5, 12, and 13 has both an inscribed and a circumscribed circle. What is the distance between the centers of these circles? So we have the triangle like that. This would be 13, this would be 12, this would be 5. Both an inscribed and a circumscribed circles. This is the circles. And then what is the distance between the centers of the circles? Okay, so we know that the 5, 12, 13. So we know that this triangle is a right triangle. So the center of the circumscribed circle must be here, right? So it's here, and the center of this would be right here, and so this would be at the, and so if these were coordinates, then this would be center of the circumscribed would be this is 5/2, so this is 2.5, comma, and this is half of 12, so this is 2.5, 6, and this of the inscribed circle would be, so let's find out, since this and this and this are and those are the same, so these two are the same, these two are the same, and these two are the same. So these two are 12 plus 5 minus 13. That would be 7 minus 3, so that's 4, right? So this is 2, 2, and so this would be 3, 3, 10, and 10. And so since this is 2 and 2, this is 2, 2. And so 2, 2 to 2, 5, 6. 2.5 comma 6, this would be 0.5, and then this would be 4. So the distance between the centers of those circles would be this would be root, yeah, so this would be root, and then 4 squared plus 0.5 squared, this is root 16 plus 0.5 squared is 1 over 4, and so this is root 16 plus 4, so 65 over 4. This is root 65 over 2. And what is the distance between the centers of those circles? So the distance is this much, so the answer is D. Number 23, each face of a cube is painted either red or blue, each with probability 1/2. The color of each face is determined independently. What is the probability that the painted cube can be placed on a horizontal surface so that the 4 vertical faces are all the same color? Okay, so this means that there's a cube here, and each face is painted red or blue with probability 1/2, right? So this would be so the total number of combinations would be that would be, what is it, 1 over 2, yeah, 2 to the 6th powers, because there are 6 faces on a cube. And so the 4 vertical faces are all the same color. That would be either these 4, so it could be these 4 like that, or these 4 like that, or these 4 like that, right? So there are 3 possible ways, 3 possible lines of the color, 3 possible lines of color, and then no, that wouldn't work. Okay, so let's say that that all 6 are the same. All 6 are the same. That would be only 2 ways, and 5 are the same. Would be 6 times, yeah, and this 6 is because we want to choose which face to paint the different color, and 6 times 2, since we don't know if the single different painting color would be red or blue. And if 4 is the same, then we would have 3, since the 2 sides have to be like facing each other, so it's either those 2, or it's these 2, or it's these 2, right? And so those are the 3 ways, and then multiplied by, we don't know if the 4 is going to be red or blue, so this would be 2, and so this altogether is 20, and the total number is 2 to the 6th power, right? So this is 20 over 2 to the 6th power. This is 5 over 16. And so the answer is B. Number 24, in ABC we have AB equals 7, AC equals 8, and BC equals 9. Point D is on the circumscribed circle of the triangle so that AD bisects BAC. What is the value of AD over CD? So we have triangle ABC. So ABC, AB is 7, AC is 8, and BC is 9. D is on the circumscribed circle of the triangle so that AD bisects BAC. This is D. And since AD bisects BAC, and if we put it on CD, then AD is the diameter, right? So this should be a right triangle. And so if we divide it by 9, then this should be 7 over 15 times 9, 8 over 15 times 9. This would be 7 times 3, so 21 over 5. This would be 8 times 3, 24 over 5. So this would be 4.2, and then 24 over 5 would be 48 over 5, so this is 4.8. What is the value of AD over CD? And these two are the same. And then so if this is a right triangle, this must also be a right triangle, right? And so this value and this value are the same. So yeah, so what we want is, so this triangle is a right triangle, right? So this is 7, this is 7, this is 4.2, and this would be root 7 squared minus 4.2 squared would be root 49 minus 42 times 42. This is 84, 8, 16, 17, 64. So this is 49 minus 17.64, and so this is root 31.36. Yeah, so it's 31.36. But then what is the value of AD over CD? And since this is the same, and since that's the similar as this, so AD over CD, this is equal to AB over, let's say this is E, AB over BE, AB over BE. This is 7 over 4.2. This is 1 over 0.6. This is 10 over 6. This is 5 over 3. So the answer is B. And our last question from number 25. So a circle of radius 1 is internally tangent to two circles of radius 2 at points A and B. AB is a diameter of the smaller circle. What is the area of the region shaded in the picture that is outside the smaller circle and inside each of the two larger circles? So we want the area of this much, right? So how can we get this? First, what we could do is get this value and then multiply that by 2, right? So to get that, what we need is 2 more lines here like that and like that. And so that will enable us to solve for this area, right? So that area is 1/3 times the whole circle, so 2 squared pi, because this is 120 degrees, right? And so this minus this triangle, right? This minus that's this triangle, so this minus, if we put a line here, then we can see that this is 1 and this is 2, so this is root 3, so this is minus root 3. So this is 4 over 3 pi minus root 3, but then we have 2 of these, right? So this times 2, that would be the total area of this whole part, and that minus, so it's 2 times 4 over 3 pi minus root 3 minus the circle, right? So this is minus pi, this is 8 over 3 pi minus pi, and then minus 2 root 3, right? Minus 2 root 3. This is 5 over 3 pi minus 2 root 3. 5 over 3 pi minus 2 root 3 is B. So the answer is B. So that was problem number 25, and thank you for watching.